Good afternoon, you guys. We have another Edpuzzle video. I know in class today we talked about those key features of exponential functions. An additional key feature of that would just be the average rate of change. But since I know this can be kind of time consuming, I just wanted to do this in a separate video instead of doing it in class. So I'm going to go ahead and just jump in now. I want to revisit a function or a formula that we talked about back in Unit 2 with the linear equations. We know that average rate of change function is going to be the change in our y values over the change in our x values. So how back in we used to do rise over run, that's the same thing as the change in y over the change in x. So that's what we're going to be doing. I have 4 examples at the bottom, and we're going to use this function to kind of work through these 4 examples. So let's see, the first example says find the average rate of change of f of x from x equals 1 to x equals 2. But we actually have a formula right here because it's telling us how to set that up. Because it says if x equals a to x equals b, then this will be that general format. So what they want me to do is figure out what is f of 2, subtract it with f of 1. And at the bottom, I would just put whatever numbers I have inside my parentheses. So that just would be 2 minus 1. So let's see if we could just actually set these up first. And I'm going to label these 1, 2, and this will be number 3 and number 4. So looking at example 2, if I wanted to set this up, I would have to do f of 4 first, then minus f of 2. And then what would I put in my denominator at the bottom? 4 minus 2. Let's see if we can do it for example 3. What will we have at the top? We should have f of 3 first, minus f of 1. Because that's what they're asking us to find from x equals 1 to x equals 3. So we do the last number minus the first number. Let's try it one more time with down here. We have from 3 to 5. So we're going to set that up as f of 5 minus f of 3. And then my denominator is just going to be what's in my parentheses. So 5 minus 3. And then let me do the denominator for number 3 as well. So we've actually set up all of the formulas that we're going to use. Now it's just a matter of simplifying, evaluating. So when they say f of 2, remember that notation, that function notation, f of x equals y? They just want us to figure out what is the y value when x is equal to 2. So we're going to go to our table, look to see where our x value is equal to 2. And that's right here. And then the y value is 2 as well. So what I'm going to be writing here is 2 first, because that's what f of 2 is. And then I have to find what's f of 1. So I need to go to my table, look and see if I could figure out where x is equal to 1. I see that in that first row. And then the y value that corresponds with that, I can see is number 1. So at the top, I should have 2 minus 1, and in the denominator, I'm just going to bring over that 2 minus 1 as well. So we only need to just figure out what those values are going to be for our numerator. So right here, I have 2 minus 1 at the top, that's just 1. 2 minus 1 at the bottom, that's just 1. 1 divided by 1, we all know that's 1. So that's telling us the average rate of change from x equals 1 to x equals 2. The slope there is 1. Let's see what the slope is from x equals 2 to x equals 4. So what do we need to do first? We need to figure out what is f of 4. We need to figure out what's f of 4. So we're going to go up to that table, see if we can find where x is equal to 4. And then I'm going to look to see what is that y value there. That y value is 8. So that's what I'm going to write because f of 4 is equal to 8. Now I need to figure out what is f of 2. But we know that it hasn't changed. I can look and see where is x equal to 2 is right here. That y value is still 2 because we know functions are 1 to 1. So if I'm putting in that same number inside the function, every time I have to get that same value back. So if Talisa goes to the table and looks for x equals 2, Goddess, Prince Thea, we're all going to get to that y value of 2. So that's what I'm going to put right here, 8 minus 2. Now at the bottom, at the denominator, I just have 4 minus 2. So I'm just going ahead and write that. I know 8 minus 2 is equal to 6. And then 4 minus 2 is equal to 2. So my slope right now is equal to 6 divided by 2. But if I can simplify that. And I know 6 divided by 2 is equal to 3. So the slope for this question, or this interval, x equals 2 to x equals 4, that slope is 3. So the slope at first was 1. The slope down here is 3. So eventually we're going to have some ways to kind of connect this and compare it to linear functions. So I'm going to save that for the end. Let's go ahead and look at example 3 and then example 4. So what do we need to do first for this example and the third box? We need to figure out what is f of 3. We need to go up to our table, figure out where is x equal to 3. Is right here, and then we see the y value that corresponds to that is 4. So that's what I'm going to write first, because I know f of 3 is equal to 4. Then I'm going to subtract f of 1. So let me see what f of 1 is. It's still 1, because I can see that when my x value is 1, my y value is 1. So that's what I'm going to put next, 4 minus 1. And then my denominator, I have 3 minus 1. So now I need to simplify. 3 minus 1 is 3. And, 4 minus 1 is 3. And 3 minus 1 is 2. I really can't simplify that. I could just say 1.5 if I wanted to. But 3 over 2, those are equivalent values. So either way is fine. So the slope for this question is 1.5. Which is the same thing as just saying 3 over 2, depending on the format they ask. So a fraction or a decimal, same thing. Let's look here at 4. They want us to find the average rate of change from x equals 3 to x equals 5. So what is the first thing that we're going to want to do since we've already set it up? We're going to want to figure out what is f of 5. So I got to go up here. Here's where x is equal to 5. That y value is 16. So that's what I'm going to put first. At the top, I'm going to have 16. And then let me see what f of 3 is. F of 3 is 4. And I can see that because I see that when x is 3, y is 4. And then my denominator hasn't changed. It's still 5 minus 3. So you guys, what we're doing is evaluating the numerator and then just simplifying. So that's all we're doing here. Let me go ahead and simplify my numerator. 16 minus 4, I know that's 12. 5 minus 3, I know that is 2. So here, the slope is 6. So let me zoom out so we can see what's going on. We had a slope of 3, a slope of 1, a slope of 1.5, a slope of 6. So what does that mean? Are we changing at a constant rate every time? Are we increasing by the same amount each time? I'm hoping that you guys have chose the answer no. We are not increasing by the same amount each time because I can see here my slope is 1. Over here I got 1.5. Down here I have 3. Over here I have 6. So if I'm going up to those intro questions, is this a linear, quadratic, or exponential function? I know that this is an exponential function because my slope, my rate of change, it's changing each time and it's changing at an exponential rate. And then I can notice, is my function continuously increasing or decreasing? Let's take a look because we talked about what exponential functions do in class. So we can look at this table and we can notice how these values are continuing to get larger and larger. And they're going to do so forever. They're just going to continue to get bigger and bigger and bigger. So we know that this function is continuously increasing. And that's going to be the case for all exponential functions. They're either going to continuously increase or continuously decrease. But whichever direction they're going, if they're increasing or decreasing, they're going to be doing that for the entire graph. So I know like we can compare that with quadratics like we did in class. We know over here is decrease, but over here is increase. So it has both. But for these exponentials, no. They just do one or the other. We're either going to grow or we're decaying. Now, I know we just did this rate of change with a table, but I know that it's a possibility that you guys will see those graphs as well. So I want to make sure that we're comfortable with using this process on a graph as well. So this question down here is about Kyra. She's monitoring the total amount of views on a math video posted by her class. So it's telling us the views at the end of the day is shown on the graph below. They want us to figure out what is the average rate of increase from day 1 to day 6. So what do we need to do to set this up? What we're going to do is we're going to do f of 6 minus f of 1. That's our first step, you guys. And then what should I put in my denominator? What should go down here? 6 minus 1. Now, I need to figure out what is f of 6. So I know at first we were using that table, but on our graph, what we're going to do is we're going to look for that x value of 6. Then we're going to go let me use another color. We're going to go up and see what that y value is. So I'm right here, and then let me see what this corresponds to on that y-axis. 85. So that's what I'm writing there, 85. And then let me figure out what f of 1 is. So I'm going to go to 1 on my x-axis. Then I'm going to go up, is right here. See what this value is. This value is 50. So we have 35 at the top. That's what 85 minus 50 is, divided by 5. What is 35 divided by 5? 7. So which answer choice should we choose? B, exactly. Answer choice B. Because we see that they were having an average rate of change of 7 website views per day. So you guys are able to do this with a graph as well as with the table. So I want you guys to just get, I think the most important thing to take away from this Edpuzzle video is that we are evaluating for these values. We're evaluating for f of 6. We're evaluating for f of 1. We're evaluating for whatever's in our numerator. And to do so, we use that table, or we can use the graph and kind of dissect the information that way. So that actually wraps up this Edpuzzle video. Enjoy the rest of your day, okay?